Okay, so in this second part, we're going to look at how to make a new risk assessment for a prac that hasn't been done before. Or it might be one that's been done before and you just want to, I suppose, do it for yourself so that you're really clear on it. So start blank risk assessment is where we're going to go to. This is our home page. We click on start blank risk assessment. First few steps are fairly self-explanatory. So author is you. Okay, experiment name. So I'm going to call this combustion, reaction, demo, and I'll just write hydrogen gas. Now, making the name nice and clear is important because you won't be able to search for this one. So I've tried to have words in there that would help people to find it in a search. Next up, we're going to look at the text reference. So this is page such and such, or book such and such. Or you could write in there that it's been emailed to Joff. Or you could also have something like share it with him in a Google Doc and put the link here. You could also give Joff a hard copy and refer to that. So you could say refer to hard copy in your office. Okay. Now make it very clear where you've left that if you haven't already discussed it with him. Teacher is usually going to be you as well. Year group. Now, the year group you're going to do this with. So for me, year 9s. Just a reminder too, you're now going to put in your chemical user codes. So just remember, 1 is if you've got a chemistry qualification. 2 if you've got a science tertiary qualification but not in chemistry. 3 is if you've got tertiary qualifications in technical and applied studies, okay, and so on. So, for example, I'm a 2 because I've got a tertiary qualification in science but not specifically in chem. Likewise, Joff is a 2. So if you're not sure about that one, that would be one to discuss with Kate, especially perhaps if you don't have a science qualification. Okay. So room, we're going to put in science 5 or whatever room you might be using. Period. Well, 6 and 7 for this one, and it's going to be at the end of the day on a Wednesday. Okay. Now, if you wanted to repeat this prac with other classes, you'd write that in here as well. Or if this was a prac that's going to be going for several lessons, you could also write that in up here as well. So you'd write those different dates in if applicable. In this case, it's only going to be a lesson I need it for. Scheduling notes. So is there anything else you think Joff needs to know about scheduling? So for example, would you like it left in the room overnight? Would you like something else done? So be really specific if you need Joff to do anything to help you with this. The list of what we're going to need. So this is literally just writing out what you need and quantities. Okay, so I'm going to start with aluminium foil. Okay. I need sodium hydroxide. I need a conical flask. Okay, and I should say back here that I need one of those. We'll say a medium one of those. We need one large beaker. Okay. We need balloons. Now I'm going to factor in for a few that don't quite go according to plan, and for the fact the class might like to do this more than once. Okay. Oop, didn't like that. So I'm going to need a stick with a candle at the end. So that's just to ignite my balloon. Joff will know what that is. And some string to hold my balloon. Okay, so we better say scissors as well. So we've got all those things. Now comes the risk assessing side of things. So we're going to go, okay, what's the equipment I need? So start from the top, you need aluminium foil. Okay, you need, now leave the chemicals out of this, so we need a conical flask. Now I just write the first word in. It's going to come up with some options. We want a medium conical flask. Likewise, beaker, and we want a large one. So we come over here, we look through the list, and we go a large beaker. We go balloons. Now some things like balloons, not a lot of options, so we just want a balloon. String, Notice didn't even give us options, so it knew what string was. Scissors, likewise, it knows what it is. Candle, likewise, it knows what it is. So I'm working my way through this list, then I'll just go through, double check. I've got everything there except for the chemicals I need, which are sodium hydroxide. Oh, helps if I spell it right. So we put that in. Now it's going to be important here as well that you're specific about what form you want that in. For this specific one, I need it in a solution, so I'm just going to choose that one. And I need to be really specific for Joff, because notice that gives a bit of a range there of what, how many moles we want it to be. I'm just going to say 1 mole. That should be more than enough for this one. Chemicals produced. So this is where you're going to be familiar with the reaction that's occurring, if it is a chemical reaction. Okay, so in this reaction, my main aim, obviously, as I discussed earlier, is to produce hydrogen. Now, there's going to be a lot of options here. The one I want is hydrogen gas generated during an experiment. Okay. Now, we also need to consider, that's what I was aiming to get, but are there going to be any products that I suppose I wasn't aiming to get? And in this case, we certainly do have that as well. So, so for this one, you need to go, alright, so what's my other chemical produced? And we'd go at sodium aluminate. So we'd go sodium. And you'll notice sometimes it doesn't actually have it in there. So this is where you want to write it into the other. And you're going to have to make sure that you've looked at the MSDS for that substance, that you're aware of the risks associated with that. Okay. Now, because I'm going to be burning this, I've also got a few other products. So I've got carbon dioxide produced. Okay. Gas during experiment. And water. Okay. Oh, actually, we should say water vapor. Oh, doesn't like that. So steam, perhaps. Okay. So we've got all of those things. Living organisms, this would be slightly different if you're running a different prac. So are any produced, are you using any, sorry, and you have to list that there. When you're happy that you've listed all of the materials you need and everything else is filled out, we go generate risk assessment. So this is just going to give you a bit of a summary. It's important you go through, double check that it's all correct. You'll notice down here, it's going to list the things that you asked for and just tell you the potential hazards with them. So for example, balloons, you need to be aware of this one, for example. So for this prac, it says, do not fill with flammable or toxic gas. Latex balloons may cause allergic reaction in some individuals. Check for latex allergies before use. So in this case, I mean, we've risk assessed this. We're going to fill it with flammable gas because of the fact that we have actually risk assessed it, and we've controlled that risk. But you would check for latex allergies. With this one, though, students aren't going to handle it, but you might just need to be aware if they are allergic. It does get, I suppose, probably over the top at times, but it's important to be aware of things like this. So beakers and conical flasks, for example, it's going to talk about the fact that they are glass. They can be cuts from chipped rims. So inspect your glassware before you're using it. Make sure it's not cracked. Make sure it's not chipped. Make sure there's not sharp areas for students. It'll also talk about, so for example, the conical flask, flat bottom of flask, prone to crack or break if dropped. So, yeah, obvious things. But once again, it's important to probably note it. Candle, okay. Once again, it's talking about the fact it's an ignition source when burning. Hot wax, there's a heat source, so be careful with it. And over here, you'll notice the standard handling procedures are also mentioned. So make sure you're following those. As you'll notice, things like scissors may be used as a weapon. That might sound silly, but for some classes, you would have to consider that as part of your risk assessment. If we look through my chemicals produced, also pretty important, I'm having a look through. Carbon dioxide, as it says, harmless in the amounts we're going to be generating. So it's not probably a factor we need to consider too much. Hydrogen, obviously it's highly flammable. That's actually why we are making it. and we actually want to ignite it. Okay, so we need to be careful there. Likewise, sodium hydroxide, hopefully as we're all aware, highly corrosive to skin and eyes and is toxic, so we're going to take care when using that as well. Water vapor, it's coming off of the combustion reaction, so once again, I mean, we've got the heat factors there, we're going to take all the due measures we need to. So we'd come down, we'd go, alright, knowledge, so do you understand the potential hazards? This is important that you're reading this, because this is what you're going to sign off on as a teacher. Have you read and understood the safety data sheets for all the chemicals used and produced? That's a really important part there that some of us may not consider all the time. And do you have copies of the safety data sheets of the chemicals available in or near the lab? So if you're not sure where those are kept, go and have a chat with Joff, have a look at the induction manuals. Have you considered all of these risk factors? Okay, and we'll talk about some of those in a minute. And then you're going to assign a risk to it. Now, if you haven't used it before, you're going to be using the school risk matrix. So, I don't think they've put the maybe they have. Here we go. So this is our risk matrix. So it's asking, what are the consequences of this? So you'll notice it gives you a bit of a key down here. So if something was to go wrong, what's the consequence? So is it insignificant, minor, moderate, major, critical? And how likely is this to occur? So is it almost certain, likely, possible, unlikely, rare? So you need to decide where that lies. So for this particular prac, I've said that it would be a medium risk practical. Okay. What control measures am I using? Well, it is going to be a demonstration. So straight away that's a control measure because I'm the one doing the experiment. I've got control over what is occurring. Likewise, are we wearing a lab coat and are we wearing safety glasses? So that really does sum up the safety measures. Okay. You would discuss things like, I suppose, warning students about the reaction. And potentially to cover ears, okay, because it could make, depending on the size of the balloon, you could be actually making quite a large bang. Ears, even though they're only doing it as a demo, this one you would still probably want to have students in safety glasses and aprons, okay, and a reasonable distance from the reaction. Okay, and lastly, I mean, it's hydrogen gas, so it's not going to spread, but other ignition sources and flammable objects kept at a distance. Okay, so that would include also having your gas taps turned off, not having any other open flames in the room, all those kinds of things. So you're saying, I've thought about the risks involved with this experiment, I've been through the risk assessment, these are the control measures I'm going to put in place. Okay, once you're happy with those, you would save them and you would sign off electronically. Now remember, by signing electronically, it's the same as if you signed it by hand. It's legally binding. You're saying that you've risk assessed this practical, that you have done all of these things mentioned up here, so that is really important. So I'd write in my name now and I'd sign. The next step is it's going to go to Joff, where he needs to also sign off on it. So to do that, I just go save, print PDF, because that gives me a copy for it as well, which is quite good. But at this point, you can just go log out. Okay, so you are done. I like to save myself a copy, but you can just log out. Make sure you've done this the appropriate time period beforehand so that Joff has time to look at it, get it ready. I hope this has been helpful.